Hi everyone, good evening. So let's start with the session. So as we know in the previous session, okay, we have learned these topics, okay, and what are the different topics we have learned, okay. First one is the introduction to data science, introduction to Python, and we also saw one example which is prediction of diabetes disease, okay. So let's go to our problem, okay. Now see, uh, one model which is random forest classifier as well as a support vector machine, okay. We also found several classifier, okay, which are nothing but the models, okay, knn logistic regression, okay. So here you can see that, okay. So I just ran this particular cell, okay, because it took some more time, so that's why I already ran this. And now we will start from after this cell, okay. So see here, okay, after tuning a hyperparameter of gradient boosting classifier, okay, we we have to tune these four parameters: n estimators, maximum depth parameter, maximum features, and learning rate parameter. And see, in this we have built multiple models, and after building multiple models, okay, here we got the best parameters, okay, and we got the accuracy for these parameters, okay. So here now we will use these parameters, okay, to build the model, okay. So now here see, this is a learning rate which is 0.075, maximum depth is 5, maximum features is 2, and n estimators equal to 50, okay. So now let's go and create this gradient boosting classifier. Let's go and run this, okay. Now here you will see that here we got the test accuracy as a 88%, and here we got the test confusion matrix, which is this one, okay. Now here you can see that in the confusion matrix, okay, we have four different units, okay. It's a 2 cross 2 confusion matrix we got. And now let me explain this confusion matrix, because when you are solving any data science projects, you have to know what is confusion matrix, because all the evaluation matrix we can found from the confusion matrix only, okay. So for that reason we have to know the confusion matrix, okay. So let's go and create new whiteboard, okay. And here see that basically in our confusion matrix, okay, so this is a confusion matrix 91, 99, and 45. So let's copy this over here, okay. 91, 9, 9, and I think 45, okay. So this is a confusion matrix. So in Python, confusion matrix is just written like this, okay. This is a true negative, this one is nothing but the false negative, this is a false positive, and this one is nothing but the true positive. Now what this term actually means, so when we talk about true negative, so it's corresponding to a class 0, okay. As we know in our problem, okay, in our outcome column we have two classes, 0 and 1, yes or no. We have two classes, 0 and 1, and here our aim is to build classification model for predicting each of these class, either 0 or 1, okay. So 0 class means negative class, okay, according to Python, and 1 class means positive class, okay. So true negative, which means that the actual data is from class 0 and predicted as a class 0, okay. This is nothing but the true negative, and the value of this true negative here is 91, okay. Now, second one is the false negative, which means that actually data is from positive class, which is 1, and model predicted that those data points as the negative class. So that's why it is nothing but the false negative. Okay, incorrect negative prediction. Okay, so the value of false negative is 9. Then we have another thing which is false positive, which means that data points are from class 0, but model predicted as those data points as class 1. So that's why false positive. You can say that the incorrect positive prediction, which is also 9. And lastly, here we have it true positive, means data points are from class 1, which you can say that positive class, and model predicts those class as a positive class, means a correct positive prediction. Okay, so that's how you can go and you can interpret this. Okay, and now why this confusion matrix is so much important in any data science project, because when we are dealing with a two class classification problem, two class means 0 1, yes no type, okay, true false type. Okay, so these are nothing but the two class classification problem. When we talk about 0 1 2, so these classification problem are nothing but the multi-class classification problem, more than two classes in the outcome column. So here you can say that when we have to find out the accuracy and the other evaluation matrices, okay, we are gonna use this confusion matrix, we are gonna use these formulas. Okay, so when we have to find the accuracy, then we just go and we just use a sum of diagonal values, which means true negative plus true positive divided by the sum of all these four elements. Okay, I can say that n. Okay, so just here you can say that just go and find out this. Okay, so I think this one is 136 and denominator is 154. Yes, so 136 and 136 divided by 154, which is nothing but 0.8831. Okay, you around 88% accuracy, around 88% accuracy. Yes or no? So this is how you can go and calculate the accuracy by using confusion matrix. Okay, so that's why confusion matrix is very much important in data science project or in any classification problem you are solving. Okay, so this is all about the confusion matrix and how you can evaluate the any model. So after this, okay, so until okay up to this, okay, we have built logistic regression model, we have built k-neighbors model, we have built support vector machine, we build the model of random forest and the model of gradient boosting. Okay, now let's go and build a very small deep learning model. Okay, so for that reason you have to import few libraries. Okay, first one is a TensorFlow, and again in the TensorFlow we have a model as well as a layer. So for that reason you have to go and you have to just import few modules in the TensorFlow library. So first let's go and import TensorFlow, then import keras from TensorFlow, and lastly import layers from TensorFlow dot keras. Okay, because this is a deep learning model, because this is nothing but a deep learning model, so that's why we have to use TensorFlow and keras libraries. Okay, and in backend TensorFlow will work. Okay, and keras will create the model, and with the help of keras, okay, we can able to add the layers in the models. So now here we just created a small function which is a built model. Okay, and here in the first line of code, so here you can see that we just created one sequential model. Okay, so in the sequential model, first layer is nothing but the dense layer with 8 units. Okay, so you can use these 8 units, okay, as the number of columns, input columns you have. Otherwise you can add more than number of units as well. So it's up to you, okay, depending upon the how much complexity you can create in your model. Okay, and activation function is relu. Relu is nothing but the rectified linear unit activation function, and we are using this rectified linear unit activation function for input layer for hidden layers, not for output layers. Okay, and it will just go and it will input data as well as pre-process data. So that's why we are gonna use this activation function in layers of deep learning models. Okay, then here let's go and create another model. So it's totally up to you how many layers you want to create. Okay, so here see, I just created one more layer, but I comment out because see, this is again, if I create this, so the complexity of model will again increase. So that's why, to reduce the complexity of the model, okay, I just comment out this particular layer. So in the second, this is nothing but the first hidden layer. First is nothing but the input layer. Second one is the first hidden layer. And here I just use 4 units, and activation function is relu. Again, I created second hidden layer with 2 units, and activation function is again relu. And lastly, here I'm going to create a sigmoid activation function with, okay, for the output layer. Okay, now here I just use 1 unit because this is the outcome. Okay, from after creating the model. Okay, starting from first model just use input data, and lastly here we'll get the output value in terms of 0 and 1. So that's why I just took 1 unit in the last layer or output layer. And here see, here I used sigmoid activation function because sigmoid, you will see that the sigmoid comes, sigmoid curve is nothing but a S-shaped curve. So it's very easy to predict values in between 0 and 1. Okay, so that's why in the output layer, when we are dealing with a two class classification problem and you are building a deep learning model, then you can go for a sigmoid activation function in the outcome layer. Okay, or the in the output layer. Now here I just use optimizer Adam 1. Okay, learning rate is 0.005. Okay, and other hyperparameters, okay, to optimize the model. Okay, and lastly here I am compiling the model, okay, with binary cost entropy as a loss function, and optimizer is the Adam one, and I want the accuracy, okay, as a evaluation matrix of each model. Okay, and let's build the model. Let's go and run this particular cell and see. After building the model, see the summary of the model, and it is a very small neural network. Okay, artificial neural network you can say. And in the first layer, okay, which is the input layer, okay, I just use the 8 units. Okay, and see, in the first layer only, okay, the model just created 72 parameters. Okay, so let's imagine, okay, if we have a very huge data set, okay, and then we will try to create the deep learning. So imagine the parameters. Okay, so that's the complexity of the deep learning model. Okay, and a neural network which is very much similar to our structure of brain. Okay, so basically see, in the first layer, okay, we are going to just import our data. Okay, the first data points, okay, of 8 columns, which are the input columns. Okay, and see, first we have the 8 columns. Okay, and we are going to use 8 units. So total we have the 64 estimators. Okay, 64 parameters. Okay, and plus, okay, we are going to add 8 is nothing but the bias values for each layer. Okay, for each value of this estimated. Okay, because this is how our neural networks looks like. Okay, so see, let's say this is the first 8 layers. Okay, okay, let me explain. Okay, so see, total we have in the data set, total we have the 768 data points. Okay, and the total 9 column. 8 columns are the input one column is a output one. Okay, so we are going to use those 8 column over here. Understood? And these are nothing but the 8 units we just created in the neural network. Okay, and we will pass our data points. Okay, like this. Okay, the first row, second row, third row. Okay, like this. Okay, so first we will pass each observation from these layers. Okay, so this first layer of neural network is nothing but the input layer. Okay, and this one is nothing but the second layer, which is also called as a first hidden layer. So here you can see that. Okay, here when we are passing the data from this input layer to this hidden layer. Okay, so I have to pass this particular data point from each of this unit of another layer, next layer. Okay, so like this we have to pass this all these units into the, okay, from the next layer. Okay, next layers units. So that's why here you can see that. So in the first, okay, here we will create the 8 cross 8 plus 6. Okay, why 6? 6 are the bias values. Okay, with the help of bias values we are going to reduce the error. Okay, and here after this, okay, now we have the 8 cross 4. Okay, 4 units are there. So for 4 units we have total 4 bias values. So first total we have the 72 parameters. Okay, we just estimated 72 parameters in the first layer. Then here we are going to just estimate the total, I think 36 parameters. Okay, and then in the second layer, okay, we just used 2 units. Okay, so 2 units, which means, okay, the 4 cross 2 plus 2 bias values. Okay, so total 10. Okay, and lastly here we have one output layer, 1 unit for the output layer, and here we'll get the output in terms of 1 or 0 or 1. Okay, so it totally depends on the data. Okay, and here we can simply create the only 3 parameters. Okay, so you, if we sum this all, okay, 72, 36, 10 and 3, so total are nothing but the, I think, 121. Okay, so in the summary here you can see that in the summary we just estimated the 121 parameters. Okay, so see, first 72, in the second layer 36, in the third layer 10, and last 3 parameters. So like this you can create the number of parameters in each layer. Okay, so if our data is big, so here we have to build the, again, the more critical neural network. So again we have to add few layers. Okay, and then we can go and we can build the model. Okay, so for this data only, okay, here we have to create 120, we have to estimate the 121 parameters. Okay, with this only 4 layers. Okay, so that's how you can go and you can create the artificial neural network by using TensorFlow library. Okay, and let's go and import model checkpoint. Okay, because now here we just go and we just build the model. Okay, with 1000 epochs. Okay, means we are going to just repeat the model 1000 time. Okay, to reduce the error of our model. So let's go and run this. Okay, and let me do this thing. Okay, after this, because here again after just finding out the all the weights, okay, we have to go and we have to select the best one. Okay, so here this one is nothing but the weights. Okay, so let's go and create the weight. Okay, and let's run this. Okay, and see in the first epoch. Okay, so basically here loss is 0.69. Okay, accuracy was 60% and validation accuracy was 75%. Validation loss was 65%. Okay, so as you are going down, okay, and see the now accuracy is around, okay, at the 104th epoch you will see the accuracy is nothing but 92% and the loss was decreased, okay, from zero point 0.6 to zero point 0.2. Okay, so it's a, you can imagine the, like, how the neural network works. Okay, and see the validation accuracy. Okay, this is accuracy for the validation data. Okay, by comparing this to accuracy we can say that yes, which model is good. Okay, so here we are just reducing the error and finding the best model. Okay, so see the accuracy is 93%. Okay, for the train, and for the validation is nothing but the 86%. And see, with the help of this code, okay, we are just saving this all the weights, okay, over here, which is, okay, this one in the weights section. Okay, see, we are just saving all the weights. Okay, and see, this is the current timing. Okay, see, we are just now we are about to save 511th model. See, so like this, here we are just saving the weights. Okay, now why to save these weights? Because these weights are nothing but the, you can say that, the 121 parameters of neural network of your model. Okay, so it's very much important to save the model. Okay, if we save the weight, so we can easily go for the model building part. We can use that particular model. Okay, and we can just go for the model building part, and we can use the same model for the deployment too. So I just took this deep learning part into this particular thing into this session, because it's again the, you can say that the, if you are a beginner in machine learning, so why not to start deep learning? Okay, because again deep learning is also very important part of data scientist. Okay, it's about to complete. Just wait a minute. And see the accuracy, which is around 95%, and see the validation accuracy 98, 82%, 83%. Again the 80, 82. Okay, 84, 81, 80, like this. Validation accuracy is nothing but the, we are just using a totally new data for the model. We build the model, okay, and we just find out the accuracy, which is this, okay, on the same data. And after this we provided a new data to the model for just finding out the validation accuracy. And see in the last, at the 100th at the 1000th epoch, okay, the accuracy of the model is around 96% and the validation accuracy is around 81%. Okay, so let's call back list. Okay, yes, we can visualize neural network in R studio. Okay, but in Python it's again difficult to visualize, because in R studio provides a one function which is just a plot function itself in the neural network library, and from that we can easily visualize the neural network. Okay, but if you want to see the neural network, just go and search for neural network images. Okay, and then you will see the a very complex structure. Okay, like this. Okay, so this all are connected to each other. Okay, like this. Okay, you will see the structure like this. See all the structures, and this is nothing but the neural network like this. Okay, and here you can see that, okay, we are just using the history, okay, for creating the last one. Okay, here you can see the last tail. uh, you can say that the last 5 entries of loss, accuracy, validation loss, and validation accuracy and epochs. Okay, so see, this is a thing over here. Okay, and here you can go for this. Okay, all the values. Okay, all the history. Okay, you can see the validation history, you can see the maximum validation history, which is around 89%. Okay, this is nothing but the accuracy of the validation. Okay, and we can also see, yes, as we know maximum value is this, so let's see 88. Okay, so see, we have so many this thing. Okay, and see, this one is this one means with this. Okay, this number 601, here we got the validation accuracy as a 0.89. Okay, so we can, after this we can just go and save this model. Okay, because here we got the highest validation accuracy. Okay, now here you can see that this is the accuracy and this is the validation accuracy. So if we compare the original model's accuracy and the testing accuracy or the validation accuracy, you can say that time wise, okay, this validation accuracy is decreasing. Okay, in the it is showing some downward trend, but valid accuracy is increasing, because each at each and every iteration, model is tried to reduce the error. Okay, so that's why this accuracy is increasing. Okay, as we are increasing epochs, and at somewhere, okay, see, from here the validation accuracy is decreasing. Okay, so that's how you can just go and you can see where we have to just like which is the best validation accuracy, and with with which model we have to go and we have to build our we have to find out the best model. Okay, so this is a neural network model, and you can see that this is the sequential model. Okay, and here you can use the predict method again. Okay, to just go for the prediction by using on the test data. Okay, and here you can just convert your neural all the predictions, okay, from probability into the 0 and 1. Okay, because if first when we go for the prediction, okay, we will get the values in between 0 and 1. So the values, as we know, in between 0 and 1, which means the values are not 0 and 1, so that's why we have to convert those values. Okay, so that's why we have to set a threshold value which is 0.05, and we are checking that each and every value, if the value is greater than 0.5, so we can simply convert it this value as 1, otherwise 0. Okay, so it's up to you, it's a subjective choice for choosing this threshold value. Okay, now let's create the list of the accuracy. Okay, this one is this. Okay, and see, we just find out the accuracy score. Okay, and here, okay, here we got the where. Okay, here this one is nothing but the highest accuracy we got. Okay, so let's save this model. But see here, first thing we have to just find out this model 601. Okay, this one is a 601. Okay, we have to just copy this. Okay, and paste it over here, and let's run this and see, we just load the all the weights. Okay, and we can use the model, this best model, okay, to predict the, to make the prediction on the test data. Okay, and we can go for the conversation part. Okay, and now you can see the accuracy, which is around 82%. Okay, and see here, we got around all this. Okay, I think we got the highest accuracy for the random forest classifier. Okay, as well as, okay, we got the accuracy of this 88%. Okay, so we are going to just save this random forest classifier model. Okay, because here we got the 89% accuracy. So let's go and just save this, okay, into the pickle file. Okay, rfc. Okay, so in the end, okay, so see here, let's go and just change this. Okay, rfc, because for rfc we got the best accuracy, which is nothing but the around 89%. Okay, so let's go and run this. Okay, and here you can see that, okay, the model, the rfc model. Okay, we just save this model rfc. Okay, and now after this, okay, after just finding out the pickle model, we have to deploy this on the Flask app. Okay, which is a web app. You can create a web app by using a Flask. Okay, so for that, okay, you have to know some amount of html as well. Okay, then you can easily create a web page. Okay, and if you know the web page, how to create the web page by using html, so it's very easy to go with the Flask. Okay, so for that purpose, okay, okay, so this is the thing. And before this, I would like to share this. Okay, this is nothing but the app.py file. Okay, and this is how you can create your app. Okay, web app by using Flask. So for that purpose, again, you have to import the Flask. Okay, from the, again, the Flask library request and the render templates. This is because of html. Okay, for this you have to just find out just you have to invoke the index.html page. Okay, then you can use that page, okay, to show your data. Okay, to read all the data. Okay, so here you can see either, so see, instead of this svm pickle, okay, svm model, okay, here I'm going to use this one. Which one? The rfc, because here we got the best model. Okay, best accuracy. So rfc, rfc. Okay, let's go and save this. Okay, and after this, this is a all the standardized the data we have. Okay, and we already pickled this. Okay, we just store the value, and see here you can see that first we are just using a app root. Okay, the first root, and here we are just returning the render template, which is nothing but the index.html. So in the index.html you can see this index.html over here. Okay, so this is my folder. Okay, and how, basically this is a vs code. Okay, and from here you can just go and open the folder. Okay, see, this is the diabetics prediction app, and I just selected this. Okay, and in this, okay, we have this many folders, okay, and this many files. We have a static, okay, this is for the Jupyter notebook checkpoints. Okay, so this is the extra folder we got. This is the first one, which is the important one. In this you will see that the CSS and the JavaScript file. Okay, and here you don't need to just write CSS and JavaScript. You can just go and you can download this CSS and JavaScript file. Okay, it's very easy. And but you have to write the templates, okay, the index one and the result HTML. Okay, and in many cases the people are just writing the HTML code, okay, in the index only, not in the result. Because see, many a times when we are just saying that when we have the data, we just input the data and we just uh, click to the button for the prediction, and then we'll simply get the prediction in the same page. Okay, so this is another page you can create, or you can use the same index HTML file, okay, to get the output. Okay, so basically this is a HTML language, and it's very easy. Okay, let me explain this all. Okay, first doc type, as we know, HTML. Okay, you can create this. Okay, you can search for this, you can learn HTML. Okay, on the open source. Okay, and here you can see that this is the head. Okay, these are the few tabs, okay, the which are important. First one is a head, okay, which we are using for the heading. Okay, and this another one which is body. Okay, there are two main tabs. First one is head and another one is a body. In the head you can just go and you can just type the title. Okay, and you can add the CSS. Okay, now here you can see that I just added the CSS. Okay, but in the CSS you will see that, okay, I didn't write this CSS. Okay, I just downloaded this CSS from here. Okay, from here. Okay, so you can also download this CSS from here as well. Okay, so this is all about the, you can say that, the beautification of the web page. Okay, and we are going to use JavaScript for processing the values, okay, for the backend kind of thing. Okay, and we are going to use HTML and CSS for front end. Okay, so this is the index.html file we have, and this is the head. In the head we have a title tab. Okay, and we just write some small CSS. Okay, to just for the beautification purpose only. Okay, and in the body tab you can see that, okay, we are just created a button for the return to home. Okay, and see, one question is there. Okay, okay, and see, after this, here you can see that here we are using the prediction. Okay, we are using the prediction. Okay, so this is again, we just created a div, the div tab. Okay, and in that we are just using a heading. Okay, and see, we are just writing few statements, okay, in HTML page. Okay, and again in the another div tab, okay, here you can see that we just use the method which is post. Okay, there are two methods of JavaScript, okay, for this all the data imputation. Okay, post and get, okay, to read the data from web page, and in the backend pre-process that data, just build the model by using that data and return the output, okay, by using web page. So see, this is the first column of our data, which is pregnancies. Okay, and I just added the, you can say that, the range of these pregnancies from 0 to 15. Okay, and second one is the glucose, range of glucose, the blood pressure, range of this. Okay, the skin thickness, insulin. Okay, I just copy paste this. Okay, and I just added, just change the names only. Okay, and see, BMI index, diabetes pedigree function. Okay, and lastly age. Okay, and here again I created a button which is the submit button. Okay, submit and prediction probability. Okay, and see, lastly I just use footer, okay, for the copyright. Okay, you can change this, okay, to create your own HTML index page. Okay, and here with this, okay, we will able to just find out the all the data, okay, by using a JavaScript. Okay, so see, you have to learn only HTML, and HTML is very easy. You can learn HTML within 2 hours. Okay, around 95% of HTML you will learn within 2 hours. Okay, and see, this is the HTML tab. Okay, so let me just again, okay, see in the app.py file. Okay, this is a Python file. Okay, and with this you can create a web page. Okay, the Flask app in your web page, and this is another the root. The two most things are there. First one is a just create a HTML. Okay, just use HTML to create a web page. Okay, and just put that HTML page over here. Okay, to use our Flask app over there. And why we have to use web app, okay, for prediction purpose. So see, again we are going to use this for the prediction purpose, so that's why we created a function which is predict. And see, here we are just adding all our data. Okay, see, this is all our data. Okay, which means you can add this much data only. Okay, you cannot add any other data. Okay, and see, after this we have to go for some pre-processing. Okay, so after just typing the data in the web page, okay, we have to convert this web page into data frame. Okay, then we can go and we can transform this data, okay, by using this, okay, standard scalar. Okay, so that's why here I have to just store this standard scalar. Okay, the pre-processing step. And see, after storing this, now we have the raw data. Okay, and now here you can see that this is our model. Okay, this is a model we just use. Okay, RFC model. And by using RFC model, here I am going to make the predictions. Okay, and after making the prediction, here you can see that we are again just created a if else statement for converting our output into the results. Okay, whether a person is a diabetic or not. Okay, so here I'm gonna use the result.html. Okay, see, here I'm gonna use result.html. So now let's see the result.html. So in the result.html, again it is very much simple. Okay, see, first heading tab, again the diabetes prediction, we have the home button we have, and here only prediction. Okay, I just created a div tab, and in that here I just have to mention the prediction with one statement, whether the person is having a diabetic or not. Okay, so, and this is a copyright, and this is a JavaScript. Okay, so this is very simple HTML language. But see, this is like many people see this, okay, I think first time. So that's why, okay, you have to learn this HTML, then you will go for this deployment part. Okay, so this is all about the HTML. Okay, and now here you can see that after just getting the prediction values, okay, here we will get the results. Okay, in terms of there is a chance of having a diabetes, or congratulations, you are safe. Okay, and lastly create a if statement to run the app. Okay, so let's go and run the app. So I can run this app over here as well, but it will take so much time, okay, in Spider. So I will do one thing. Okay, I will open the Anaconda prompt, okay, which is already there. Okay, after installation you will see the Anaconda prompt, Anaconda PowerShell, Spider, and Jupyter Notebook. Okay, first thing is that I have to convert this current directory is this. Okay, but my all the model, all the data is in this particular folder. So let me just copy this folder path. Okay, let me just go here and just type C and D for change directory. Okay, and paste this path over here and let's enter this. Okay, so see, we just change the path. Okay, after changing the path, we know that now the Anaconda prompts path is this folder. Okay, now it's very easy to just extract this app.py file from here. So now here we know that, okay, this is a Python file. So first thing, we are going to type Python, okay, space app.py, enter. Okay, now see, here we got the link. Okay, let's copy this. Okay, and paste it over here. Okay, and see, this is a web page. Okay, and basically as I created a HTML, okay, with some CSS, okay, and the JavaScript, so that's why, see, now it is very much you can see the, it's very simple, okay, to understand. Okay, and now here you can see that you can just go and you can use any values. Okay, so let me just type any random value in between 0 to 15 for these pregnancies. Okay, and we will see the prediction probability. Okay, so let's go and let's see one. Okay, and glucose, let's 50, blood pressure around 90 is, I think, normal one. Okay, in between 80 to 120 blood pressure is normal. Okay, the normal range of blood pressure. Skin thickness, let me go with 20. Insulin, let's go with 600. BMS, let's go with 26. So it's totally random. Okay, you can type any random values. Okay, and see the probability. Okay, now see the here we got the prediction. Congratulations yourself, probability of you being a diabetic is 25% only. And again, if you have to again go and again make the prediction, so again we can just use this button. Okay, to again redirect this page. Okay, basically, see, HTML, you can learn HTML from any open source. Okay, so you can use YouTube as well to learn HTML because it's very much simple. Okay, uh, I like totally like believe that in 1 to 2 hours you will understand all the HTML. Okay, around 95%. Okay, you will learn HTML in within 2 hours. Okay, okay, so that's all about this project, which is a classification more project, and this is a two class classification project, which is a prediction of diabetes disease. Okay, now after this, let's go and um, let me end this. Now after this, let's go and just create another projects. Okay, so see, I have different projects and I also created a zip file. Okay, to share this app, this all the files with you, all the material with you. Now let's go with the car price. Okay, now here you can see that this is a car price prediction, which is a regression problem. Okay, now what is the difference between classification and regression problem? Basically, when we say classification problem, which means that our target column or our outcome column contains discrete values 0 1 0 1 2 like this, or yes no value, true false value. Okay, like these values. When we talk about regression problem, which means we have to predict a numerical outcome, numerical value. Okay, in terms of you can consider this value as a continuous value. Okay, so this is a car price is a, a numerical value. Okay, so this is nothing but the regression problem. Okay, so let me save this. Okay, and now let's go and see the all the data collection, data pre-processing step, model building step, and model deployment step of this regression problem. Okay, so now, as we know, in the classification problem or in any data science kind of task, okay, we have to use few libraries which are very much important in Python. Okay, first one is the NumPy, second one pandas, matplotlib, and seaborn. Why? Because we know that with the help of NumPy library, we are gonna use, okay, we are gonna create n-dimensional arrays. Okay, we are gonna apply some statistical data analysis, some linear algebra on our data. Okay, as well as with the help of NumPy and pandas, we can analyze our data. Okay, we can some we can do some data wrangling steps. Okay, and we know that pandas is the most famous library for the data wrangling as well as the data analysis and as well as to read the CSV data. Okay, and very much different kinds of data, very much format data you can read with the help of pandas library. Then we have a matplotlib and seaborn. We know that these two libraries are for data visualization. Okay, so let's before this, let's clear the output. Okay, and now let's go and run this cell. Okay, and after this, here you can see that, okay, after importing libraries which are important for our analysis, let's go and read our data. Okay, now this is a car data we have. Okay, and here you can see that this is how our data looks like. Okay, now we have to predict the selling price. Okay, we have to predict the selling price. Okay, because this is nothing but the car price prediction. Okay, so in that we have a most of the cars are you can say that the second hand like cars. Okay, we have, and this is nothing but the car price prediction model we have to build from this data. So first we have a car name, year, selling price, present price, kilometers driven, and fuel type, seller type. Okay, transmission owner. Okay, so now here you can see that first thing is that we have to know what is our objective. Okay, what is the problem statement? So first, this is a car price prediction, so that's why we have to predict the price of the car. So here we have two prices, selling price and present price. Okay, but here we have to predict the selling price. Okay, we have to predict the selling price, which means that selling price is nothing but the outcome column. Okay, and in terms of statistics you can say that this is the dependent column. Okay, and all the remaining columns are nothing but the input column. You can also say that these columns are nothing but the independent column. Okay, why the selling price is dependent column? Because we are going to create model based on all the remaining columns to predict the selling price. Okay, so that's why this is a dependent column on all the remaining columns, and all remaining columns are the independent columns. Okay, you can say that variables, you can say that features. Okay, it totally depends on you. For one term there are various names. Okay, now let's first thing is that let's go and check the missing values. Okay, so we know that with the help of is null method, okay, we can simply just check the missing values in our data. Okay, column wise. So here you can see that, okay, all columns show zero value. Okay, which means there are no missing values in our data. Okay, so now let's go and see the unique values. Why unique values? Because few columns are the categorical values. Okay, categorical columns we have like fuel type, seller type, transmission, car name. Okay, so for that reason owner as well. Okay, so for that reason we have to go and we have to just see the exact unique value in our data. Okay, when we say in our input data, okay, input data, unique values are few, okay, then we can simply go for analysis, okay, for after converting the data, okay, from this categorical to numeric, okay, by using 0 1 2 like this, okay. So for that reason, let's go and see the unique values, okay. So with the help of unique method, we can simply go and find the all the unique values in individual column, or even you can just go and you can use you can find out the unique value from all the data in one go as well. So see, in the seller type, there are only two values, dealer and individual, okay. Fuel type, petrol, diesel and CNG. Transmission, manual and automatic, okay. Owners 0 1 3, and the years, you will see the number of years, okay. And in the car name, we know that there are very much different brands, okay, exist, okay. So that's why let's see the total n unique means we have to just see the number, okay, number of unique values in this particular column, okay. So see, there are 98 unique values in this particular column, okay. So here you can see that car name is not important, okay. What important is year, selling price, all these things, all the remaining columns, okay. So that's why, okay, probably we are going to drop this particular car name column, okay. So let's go and describe this first, okay. See, with the help of describe method, okay, we only describe a numerical data, because here you can see that we can't describe the data, we can't find the mean, standard deviation of the categorical data. This is a text data, categorical data, string data. So that's why we can't describe any quartile, we can't find out the mean, minimum value, maximum value like this. So that's why here you can see this only numerical value, okay. Count, mean, standard deviation, minimum value, maximum value, all these things, okay. After this, here you can see that, okay, why we go for describe, why we go for summary statistics. This is nothing but the summary statistic, okay. Why we go for this? Just to see the all the mean, standard deviation, maximum, minimum value, median value and all this, okay. And this will help us, okay, to understand data, okay, whether we have to transform the data, whether we have to just add different statistical analysis on the data or not, okay. So like this. So now here you can see that we are going to drop the car name column, okay, because this column is doesn't make any sense, okay. So that's why we just drop this particular car name column, okay. So now this is our data, okay. And basically here you can see that, okay, this is a present year, okay. So we can convert this, okay, from 2020 to 2022, okay. This is totally up to us, okay. So let's convert this, okay. Here also you can convert this, okay. See, this is a markdown cell, okay. And this is the present year, okay. We just, here we are going to create the new column, which is this, okay. And basically why we create this, because we have the year column, okay. See, we have the year column in our data, and present year is nothing but the 2022, okay. And basically, for we don't have the number of years that car, like we don't know the age of the car, okay, the number of years old that car. So that's why for creating new column, okay, for creating new column, which is this, okay, we just created this column and we have this column, okay. So let's subtract, okay, the year column from this, okay, to get this. So let's go and run this, okay. And now we got this number of years old car, okay. And after this, okay, as we used these two particular columns, now these two columns makes no sense, okay, because we just grab the information, we just extract the information from these two columns, and now these columns are not important columns for our analysis. So that's why let's go and drop these two columns. Okay, so by using drop methods, see, I'm gonna drop these two column here and present here axis equal to 1, which means drop the columns. Okay, axis equal to 0 means drop the row. Okay, in place equal to true, which means that, okay, just make changes in original data set. So here I don't have to just store this again new data into the with the new name. So see here, I didn't store this data. Okay, I just use a data set dot drop method, and with the help of in place means I am making changes in this data set itself. Okay, so now see, I just drop these two columns here and present here. Okay, and after this, here you can see that now we have the fuel type, seller type, transmission. Okay, these three are nothing but the categorical column. Okay, so now we have to use encoding for convert this categorical column into numeric column. Okay, so we have so many types for converting this categorical column into numerical column. We have one hot encoding, we have the get dummies. Okay, now get dummies is nothing but the pre-processing step by using pandas library. But if you have to apply any another categorical encoding, then we have to use sklearn library. But here I'm gonna use get dummies method for transforming this categorical columns into numerical columns. Okay, so basically see, when we say, okay, we have a categorical data. Okay, so let's say in this data, okay, in this particular column we have only two types. Okay, petrol and diesel. Okay, let's assume that we have only two types, petrol and diesel, and we created a dummy columns. So which means that I'm gonna create two dummy columns, because here we have the two different unique values in this particular fuel type column. Okay, and when in the first column, in the fuel type petrol column, okay, we have a 0 1 value. Okay, 0 means the not petrol indirectly, which means that diesel car. Okay, and 1 means petrol car. Okay, so that's why to just again use the another column for diesel. So that's why I'm gonna drop the diesel column. Okay, likewise I can do the same thing for remaining two columns too. Okay, so that's why here you can see the drop first. Okay, I just use a drop first equal to true, means drop any one column. Okay, if we have the two class, okay, two unique value in the column, then drop one. If we have the three, then drop one. Okay, like this. Okay, if we have 10, so then drop one, and in the last we'll get the 9 columns instead of 10 columns. Okay, so I'm gonna apply get dummies method on the fuel type, seller type, and transmission. Okay, and see, after just transforming this data into the meaningful information in terms of 0 and 1, okay, then there is no need to again just use this data. Okay, so that's why after transforming the information in terms of 0 and 1, I'm gonna drop these three columns. Okay, so see, in the last I'm gonna drop these columns. Okay, and see, here I just transform this data by using get dummies. Okay, and here I'm gonna concatenate. Okay, use a concat method to again merge this two three columns. Okay, in our data set. Okay, so let's go and run this. Okay, now see here, we have a fuel type diesel, we have a fuel type petrol, we have a seller type individual, we have a transmission manual. Okay, so now here you can see that, okay, now we just transform our data from this categorical data to this 0 1 data. Okay, and now we can see the column names. Okay, these many columns name we have. Okay, and we can see the correlation matrix. As we know, the correlation is nothing but the finding the relationship between the two columns. Okay, finding the relationship between the two columns. Okay, And this correlation, this is nothing but the correlation matrix. We can use any one triangular matrix, either lower triangular one or the upper triangular one. So here you can see that most of the correlation is around 0.5 or 0.1, 0.05. Okay, some are negative, some are positive. So I can say that yes, okay, most of the correlations are just very less or very negligible. So that's why I can say that yes, about like around all the columns are the uncorrelated. But here we have so many numbers to see na. So that's why, okay, I'm gonna create a heat map, okay, or you can say that correlation map, okay, to see the correlation. Okay, now here you can see that the correlation value, okay, 0.2, 0.08, this is a negligible values. Okay, now this is nothing but the 0 minus 0.52, which is nothing but the correlation between year and kilometers driven. Okay, as well as the correlation between selling price and the present price. Okay, but when we talk about selling price is nothing but the our target column, and we have to build the model for the selling price. So that's why, okay, and we know that the selling price is the dependent column. So there is relation between the columns, which means that yes, there is some dependency. Okay, so that's why we can't we can't consider this particular row column as well as a particular row for the selling price this. Okay, and other than this we have this okay, this value. Okay, but this value again on a very threshold point. Okay, this is not either a not correlated or not strong correlation. Okay, this is nothing but in the middle. Okay, 0.5. Okay, this is a negative poor correlation, I can say. Okay, so here you can say that we can go for the further analysis, because again all the like near about all the columns are showing a no correlation. Okay, because we have the value, so that's why we, okay, here you can see some kind of correlation value, but this correlation value is very much small. So that's why we can say that yes, there is no correlation. Okay, now let's split the data in terms of x and y. Okay, we know that this is the price, and selling price is a dependent column. Okay, we have to build the model for prediction of the selling price. Okay, so that's why let's split this. Okay, first extract the selling price from the data and drop this, okay, from the data set. Drop this particular column, and now here you can say that, okay, now join the selling. Okay, because first selling price is the second column. Okay, now I'm converting this column from the second column to last column. See, now we selling price, okay, is the last column. Okay, now it's very easy to split the data. Okay, it's very easy to split the data. Okay, I can take first this, okay, up to this column. Okay, I can take all the columns are the x column, or you can say that input columns, and last column is the output column. So let's go and run this. Okay, you can say that with this index location method, okay, see, I'm just extracting all the rows, okay, all the columns except last one. Okay, this is a -1. Okay, and here in Python we are not going to include the last column. Okay, so that's why except last column, take all the columns in the x data set. Okay, and here you can see that I didn't add a column here, so that's why I'm extracting only last column, -1 column. Okay, -1 index column. This is -1 is nothing but the negative indexing. Okay, so let's go and run this. Okay, and after this, here, as we know, we have so many machine learning algorithms, okay, for regression problem, for classification problem. Okay, so in classification we know that we have logistic regression, k neighbors classifier, we have naive bayes, we have support vector machine, we have decision tree, we have random forest, gradient boosting. Okay, in the same way we can use the same algorithms for the regression. Okay, there we used classifier. Here we have to use regressor. Okay, here we have to use regressor. Okay, we just change the mathematical intuition behind these algorithms. Okay, now here I can use this same algorithms for the regression problem, to solve the regression problem. And even we have a lot of regression algorithms as well. But many times you will see that when you are dealing with regression problem, okay, so in the start, okay, you can go with a multiple linear regression, you can go with a exponential regression, non-linear regression, okay, like this. And if you want a high accuracy, okay, those regression analysis methods will just didn't give you the accuracy, that much accuracy that you want. Okay, so in that case you can use the different algorithms of machine learning to solve these problems of regression. So that's why here I used a extra tree regressor. Okay, this is the extra tree regressor. This is again the ensemble technique. Okay, and here I'm gonna create this technique. Okay, I'm gonna extract this model from the sklearn.ensemble module. Okay, I just store this model equal to model. Okay, and I'm gonna use this model to fit this model on our data, which is x and y. And remember, if you are using sklearn library, you have to split your data in terms of input and output. Input means x, output means y. Okay, then after that, okay, this ensemble techniques will give you the very popular step of any data science project, which is feature engineering. Okay, these algorithms can just find you, okay, the best features for your analysis, for your model. Okay, so here you can see that I'm gonna use the model dot feature important part of this extra tree regressor, and I'm gonna plot this. Okay, I'm gonna plot this. So let's go and run this. And now here you can see that after building the model, okay, now you can see that we have a the highest relevant column or highest important feature is nothing but the present price. Okay, and why it is highest? Because here you can see that the correlation between this present price and selling price is 0.88. Okay, so there is some kind of relation between present price and correlation. Okay, so that's why you can say that yes, this should be the, this present price should be the highest important feature, okay, for this problem. Okay, this is the present price highest important feature. Then second top feature is fuel type diesel. Okay, like this we have the remaining columns. Okay, now here you can see that owner has a zero feature. Okay, zero feature importance value. Okay, so which means that, okay, this owner is not going to add some kind of information for creating model. Okay, so that's why, okay, here you can just drop this column. Okay, or even see this is a small data, so then in that case you can even use this column too. Okay, this is totally up to you. But most of the cases, if the column is not important and there are a lot of column in the data, so you can remove that column. Okay, you can remove that column. Okay, after this, okay, this is nothing but the feature important step. After this, let's go and build the model. Okay, now we know that while building the model we have to split the data into training and testing. Okay, so let's go and split the data into training and testing. Okay, so first, okay, let's split the data into x and y, input and output data set. Okay, and see here, before building the model I have to just import few evaluation matrix. Okay, first one is the cross validation score from the model selection, then absolutely matrix. Okay, which means we can just extract any matrix with the help of matrix. Okay, this metric. And here this is a regression problem, so that's why I have to find out the error. Either we have so many error formulas. We have residual mean square error, we have mean absolute square error, we have mean square error, we have mean absolute error, we have mean absolute percent error. Okay, we have so many errors, and here the main thing is that we have to reduce the error. Okay, and here for that reason I have to import this mean absolute error, mean squared error to see the error, okay, of the model. Then I can say that which model is best for our data. Okay, so after that let's go and import train test split to split the data into two different data set, training and validation. Okay, and see here I'm gonna import these from sklearn.model selection. Okay, and here you can see that, okay, I'm using this, okay, x train, x test, y train and y test. Okay, these are nothing but the four data set I have to create. Okay, and this order is very much important, okay, to split the data. Now I added here x and y input and output data set and test size equal to 3. Why it is so important to just select the test size? Because, okay, the default value of this test size is 0.25, 25% of overall data. Okay, you can go for the 70-30 pattern, you can go for the 80-20 pattern. Okay, 80-20, which means 80 in the train data, 20 in the test data. Okay, so here I'm gonna use the 70-30 pattern. Okay, and which means 30% of data in the test data set and the remaining 70% of data in the train data set. And now here I'm gonna use a random sampling, okay, instead of stratified random sampling. So here I'm gonna use a simple random sampling, okay, not the stratified random sampling. So these are the different sampling types. Okay, you can explore this by just searching on internet. Okay, random state equal to 0, which means that, okay, just get the same training and testing data set when I am running this particular cell. Okay, every time I will get the same train and test data set. Okay, so let's go and run this. After this, let's go and create a decision tree regressor. Okay, so now see, after splitting the data into training and testing, okay, now we have to build the model. Okay, we have to train the model on the train data set. That's why it is called as a train data. And then we are going to make the prediction on the basis of test data. Okay, so that's why here you can see that first thing is that, okay, I'm gonna import decision tree regressor from sklearn.tree module. Okay, so in the tree module, okay, we have one decision tree regressor as well as decision tree classifier. Okay, so this is the regression problem, so that's why decision tree regressor. Okay, and here you can see that decision tree regressor with random state equal to 0. Okay, and this is a parameter for not repeating the results. Okay, to stabilize the result. Okay, for this I'm gonna use this random state equal to 0. Okay, you can add any value. This is a any you can take any integer value over here. Okay, then after this, okay, as I store this decision tree regressor model is equal to the dt decision tree regressor. Okay, so I'm gonna use the same model to fit on the data, which is the train data. So after this, I'm gonna make the prediction by using a test data. Okay, and see here, I'm gonna find out the training accuracy and the testing accuracy. Okay, and after that, okay, I can find the cross validation score. Now what is cross validation? Okay, so let me explain this cross validation, because many of you who don't know cross validation and why we are using cross validation. So let's say we have the data. Okay, so we have the 100% of data. Okay, we split it into, let's say, 70 into train, okay, and 30 into test. Okay, but in the 70% of data, we don't know like how much data randomly we got, okay, from this 100%. Okay, after getting this data 70%, okay, now if I want to use the cross validation equal to 5, which means I'm gonna split this 70%, which is a trained data, okay, into 5 different parts. Okay, 5 different parts, 1 2 3 4 5. Okay, after splitting these, okay, now I'm gonna use this first 4 part, okay, for training the model, okay, to train the model, and last part for prediction. Okay, for prediction. After this, I'm gonna repeat this step, okay, 5 times. Okay, but now I will change the sample. I will change this 5 split part. Okay, now I'm gonna use 1 2 3 5, okay, for building the model, and last one 4 to predict the model. Okay, like this, here you can see that 1 2 4 5, okay, like this. Okay, which means, okay, I will create 5 different models. Okay, and as well as I will get the 5 different models accuracy. Okay, so see here, okay, as cross validation is nothing but 5, so for that, okay, here you will see that, okay, cross validation equal to 5, and in many cases you will see cross validation equal to 5. Okay, so see, I'm gonna use a model training data, okay, X train and Y train, and I can find out the accuracy. Okay, so see, this is a cross validation score. So then I will get the 5 different accuracies, okay, of 5 different data. Okay, and I will print those accuracies. Okay, and after this, I will find the mean of the accuracy, okay, of this all the cross validation score. Okay, and as well as the standard deviation. Okay, this is because to see the how much variation, okay, is there in each model. Okay, then I can go with the mean absolute error to find the error of the model, as well as I can go and find out the error by using a mean squared error. Okay, so it's totally up to use to each one, okay, or multiple. Okay, and it's sufficient to use only one error. Okay, and it's sufficient to compare only one evaluation matrix. Okay, because see, this is a mean absolute error, and if you are comparing this mean absolute error by the mean squared error, so this is not the, you can say that the proper, uh, you can say that the proper working. Okay, so if you go with a mean absolute error, go with that. Okay, and after creating each model, just find out the mean absolute error. Mean absolute error is nothing but the let me just write the formula for this mean absolute error. Okay, mean absolute error is nothing but the mean of, okay, we know that how we find the mean summation of all these things. Okay, observations. Okay, mean absolute error. So here you can see that why your original data, and this is the predicted data. Okay, so this is nothing but the error. Difference between actual and predicted value is nothing but the error. Okay, and you are just finding out the absolute value modulus, and you are just finding out the mean. Okay, so this is nothing but the mean absolute error. Okay, now what is mean square error? Mean square error is nothing but the, again, the mean and the error square. Okay, mean of this is the mean square error. Okay, RMSE mean, root mean square error. Okay, just square root of MSE. Okay, likewise we have so many errors. Okay, and it's very easy to calculate. Then after calculating this, okay, you can even go for the RMSE. Okay, and this lastly R square. Okay, now R square is a, I can say that most important evaluation matrix, because you can say that, okay, the interpretation of r square is very much relatable. Okay, you will understand the interpretation of r square. Okay, so let's say model gives a 90% r square value of the model is 90%, which means that, okay, model is just explain model is able to explain 90% of information of your outcome column by using input columns. Okay, so this is the information, this is the interpretation of r square. Okay, also called as r square coefficient of determinant. Okay, and in other terms, okay, I can say that the when means in a simplified way, r square is nothing but, let's say, uh, if I have one friend. Okay, so if I wanted to know, like, someone has a one friend and I wanted to know the information about him, okay, from his friend. Okay, so in that case, if I ask any information, okay, so then 90% of information, okay, of him, his friend can able to give me, because r squared value is 90%. Okay, so which means that I can extract 95% information of yours from your friend. Okay, so this is the interpretation of r square. And after this, here you can see that I'm gonna use a seaborn library, seaborn, okay, sns dot dist plot, okay, distribution plot, and lastly as well as the scatter plot. Okay, for just checking the, is there any relation between the actual value or actual output value and the predicted output value. Okay, so let's go and run this. Okay, cross validation score is not defined. Okay, so see, we got the error, and error says that cross validation score is not defined. Okay, so here I didn't run this particular cell, so let's go and run this. Okay, now let's again go and rerun this cell. Okay, now here you can see that decision tree score is 100%. Okay, here first decision tree score is 100%, means the training accuracy is 100%. Testing accuracy was 92% around. Okay, 92%. Then after this, okay, I just find out the cross validation score by using a cross validation value equal to 5. So here you can see that the I got the 5 different accuracies. Okay, so I explain this cross validation, okay, in the whiteboard. Okay, so you will understand now. Okay, so that's how we got the 5 accuracies. Okay, and the mean of all these accuracies is nothing but 86%. Okay, and the standard deviation is around 9.45%. Okay, so there is around 9.45% variation, okay, in between these accuracies. Okay, mean absolute error is nothing but 0.85, mean squared error is nothing but 2.45, because it is square, so that's why you can see the some this mean square error is larger than this. Okay, RMSE is nothing but the square root of this mean square error, so you can see 1.57. Okay, so and the lastly r square. Okay, r square is nothing but the 0.91. Okay, we know that why we are using error. Okay, our aim is to reduce the error of the model. Okay, and in the end I'm gonna select the model which gives a least error. Okay, so as well as the model gives a highest r square value. Okay, so in the regression, okay, there are most important evaluation matrices, which are r square, adjusted r square, mean absolute error. Okay, and you can even go for the training testing accuracy. Okay, because see, this is a numeric problem we are solving, so that's why r square error is the, you can say that, best evaluation matrices instead of accuracy. Okay, and see here, in the regression problem, the first thing is that we have to check so much assumptions. Okay, the first assumption is the error should follows normal distribution. Okay, so we know that. Okay, here we can simply find out the errors distribution plot. Okay, this is actual data minus predicted data. Okay, actual minus predicted, so this is nothing but the error, and I'm gonna create a distribution plot. So I created distribution plot, and see the this distribution plot looks like a bell-shaped curve. Okay, which is looks like a bell-shaped curve. So bell-shaped curve is nothing but a this data follows a normal distribution. Okay, so this one assumption satisfied. Okay, and most of the cases this assumption is very much important. Okay, error should follows normal distribution. And after that, here you can see that is there any relation between actual outcome and the predicted outcome. When we say there is relation between predicted outcome and the actual outcome, which means that yes, I'm on the true path, because here our aim is to make the prediction. Okay, and if the relation between these two, which means okay, these two are 90% same. Okay, which means they are 90% same. Okay, or you can even say that there is, see, why prediction. Okay, there is 90 around 92% variation of outcome column is explained by input columns. Okay, wait okay, so here you can see that. Okay, so in the scatter plot it is uh, this scatter plot shows a upward trend. Okay, in a straight line, so I can say that there is a strong positive correlation. Okay, so if you find out the correlation between y prediction and the actual value y test, okay, you will get the correlation value around again 90% or more than that. Okay, so here r square value is a around 92%, which means there is 92% variation of outcome column explained by input columns. Okay, after this, okay, this is a, you can say that the another algorithm, which is a decision tree algorithm. Okay, first we find out the for feature engineering we use a extra tree regressor. Okay, this is a another algorithm. And now we are gonna use a random forest regressor. Okay, first we use decision tree and random forest. Now can you see some relationship between decision tree and random forest? Okay, decision tree, which means it's something like tree like structure. Okay, it's something tree like structure. Okay, and random forest is nothing but, as we know, in forest there are lots of trees. Okay, so in the same ways in the random forest we are gonna create lots of decision tree models. Okay, and from that we can just draw the prediction, we can make the prediction. So see here, now I'm gonna import random forest regressor from sklearn.ensemble module, and I'm gonna store this as a RF regressor. Okay, with n estimators equal to 400. Now this is very much important, n estimators of the random forest regressor, which means that n estimators are nothing but the number of trees we have to create for this model. Okay, so here I'm gonna create 400 decision tree. Now just setting this value, selecting this value, it's totally up to you. You can create 1000 tree, you can create even 1 lakh trees as well, depending upon your systems. Okay, then minimum sample splits, so it's a parameter of decision tree as well as a minimum sample leaf. Again, it's again the next parameter of the decision tree. Okay, and these parameters are the decision tree parameters. Okay, and this parameter is a number of trees we want for our for building the our model. Okay, and after that we are gonna fit our random forest model on our train data, and I'm gonna make the prediction on the test data. Okay, and see again, I'm doing the same thing, finding the training accuracy, finding the testing accuracy by using the score methods. Okay, then I'm gonna find out the cross validation score. Okay, and then find out the mean of all these cross validation scores, okay, as well as the standard deviation. Then I'm gonna find out the error, mean absolute error, mean square error, as well as the RMSE, root mean square error, as well as the R square. Okay, as well as the same distribution plots for the error, but by using a we will get the predicted values by using our random forest. Okay, by using this, okay, random forest model, not by using a decision tree model. Okay, so this distribution plot would be different. Okay, and the scatter plot in the last. Okay, so let's go and run this. So see, the accuracy for the training is nothing but around 91%, for the testing is around 87%. Okay, and you will see this. Okay, the cross validation scores. Okay, because here I used a 5 cross validation. Okay, so that's why here you will see that the 5 accuracies. Okay, the mean of the all 5 accuracies, standard deviation of all 5 accuracies. Okay, mean absolute error is nothing but around 0.87. Okay, I think this is a this is the best one. Okay, and here you can say that the 3.87. Okay, again if we compare these two, okay, this is the mean absolute mean square error 2.49. Again this one is the best. Okay, RMSE is also low, 1.57, and here you can see that the 1.96. Okay, so if we compare these two, okay, then you can say that decision tree regression model is better than this. Okay, now here also in the R square, decision tree gives around 92%, but here R square value is 87%. So if we compare these two, so decision tree regressor model is the best one. But remember, when in the decision tree, when we got the overfitted model, so we can go for the highest one or the extension of the decision tree, which is nothing but the random forest, or you can even go for the extreme gradient boosting techniques. Okay, so see, let me explain the thing, okay, of overfitting, then you will understand in a more correct way. Okay, so see, basically we have the three different data points. Okay, like this, let's say we have this data. Okay, again we have this data. Okay, and see, we have again this data. Okay, so when we say, okay, so see, this is our data and we just go and we just build the model like this. So this is, I can say that the error is very high. This is actual, this is the predicted data point, so error is very high. So this is the case of underfitting. Okay, this is a case of underfitting, or you can say that underfitted model. Okay, when you say this is the data, okay, and you created the model like this. Okay, the non the model, but here you will get the error which is less. Okay, as compared to this. Okay, so see here, now again you can, let me create this. Okay, okay, so like this, and you created the model like this. Okay, like this means you will get some kind of error. Okay, but not the 100% accuracy. Okay, then you can say that this is a balance one. Okay, this is a balance one. Okay, and in the last, and you created the model like this, which is passing on each and every data point. Okay, so like this. Okay, so if the model is passing through each and every data point, which means this is a overfitted case. Okay, yes or no, this is a overfitted case. Okay, so this is not true. Okay, this one is a wrong model. Okay, this one is also the wrong. Okay, we have to find out the balance one. Okay, so you can again understand this. Okay, in this way. Okay, because see, we have the data point like this. Okay, we have the data point like this. This is a one, this is again, See, okay, and lastly the same one. Okay, now you can say that the shape of these three plots are about same. Okay, now in the first I created the model like this, so this is the underfitted. In the second case I created the model like this, so this is a balanced one. Okay, here I'll get the some kind of error. Okay, so again I can say that this is a balanced one. But what if model tries to pass through each and every data point? So in that case I can say that yes, model is overfitted. Yes or no? Model is overfitted means the model is trying to grab the information of each and every data point. Okay, so if that will be the case, so I can say that model is overfitted. Okay, and the model is totally wrong. These two models are totally wrong. I want to find this model. Okay, this is the balanced one model. Okay, so this is the case. So that's why instead of using decision tree, okay, you can use random forest or you can use any boosting models. Okay, this is the bagging model. Okay, and this is again here you can say that this is the normalized error. Okay, you got, and here again there is a relationship. Okay, here you will see that yes, again there is a strong positive relationship. Okay, because here you can see the r square value which is around 87%. Okay, which is not bad. Okay, and I can say that yes, 87% of variation of output column or the selling price column is explained by remaining columns. Okay, this is a interpretation of r square, and that interpretation is very much important. Okay, and then after this here we have a voting regressor, another ensemble technique. Okay, another ensemble algorithm, and here you can say that voting, I'm gonna use these two models, okay, which I created above, and I'm gonna fit the voting regressor on the train data and make the prediction on the test data. Okay, and this is the training accuracy, this is the testing accuracy. Okay, and this is all the same step. Okay, let's go and run this. And here you can see that, okay, here the voting regressor accuracy for the training is nothing but the 97%. Testing accuracy is around 89%. Okay, the accuracy is also increased for the mean accuracy for this cross validation scores. Standard deviation uh, is bit same. Okay, around 10%. Okay, and the mean absolute error is decreased 0.84. Mean square error is also decreased 2.99. Okay, rms is decreased. Okay, and r square value is also decreased. Okay, because of decision tree is a overfitted model, that's why I'm not going to use this model for our deployment case. Okay, for the model deployment part. Okay, so if we compare this random forest and voting regressor, okay, so which one is better? Absolutely the second one, because here I got the accuracy which is higher than random forest. Okay, so that's why I'm gonna use this. Okay, and I'm gonna just read this. Okay, I'm gonna dump to this, okay, to the pickle file. Okay, means I'm gonna store this as a pickle model. Okay, so let's go and run this. So after, see, here I'm gonna create a pickle file. Okay, and here also you can just go and load the pickle data. Okay, and here also you can go and make the predictions. Okay, this also makes sense, but here I want to create a web app, because if the people who is from non-technical background, who don't know anything, okay, so that's why I have to create a one app which is very much comfortable to understand anything. Okay, so that's why let's go and create the app. Okay, no, okay, so this is for the diabetes prediction app, and car price. Okay, so here you can see that this is the app we have. Okay, and let's clear this. And here also you can see that, okay, from Flask, okay, I'm importing Flask render template for HTML as well as a request for just loading the data. Okay, and I'm importing pickle numpy library as well as a pre-processing, which is a standard scalar. Okay, so in the previous classification project, okay, instead of loading this numpy and pre-processing, I simply created a one pickle file and I loaded that pickle file over here, okay, for the pre-processing step. So there is no need to again go here and make the pre-processing. Okay, but here I didn't save any pre-processing step. Okay, so that's why I'm gonna just do all the pre-processing here. Okay, and here you can see that first thing is that app root. Okay, with the help of app root, I'm gonna create a home function, okay, for the HTML. Okay, so this is just the name. Okay, you can create a function with any different name. Okay, this is totally up to you. Okay, but here in the return, okay, you have to mention render template with your HTML file. Okay, and let me show you the HTML file. Okay, so this is a total folder of the diabetes prediction. So now let's go and open the folder of car price prediction. So let's select this, select folder, and see here this is a car price prediction folder we have. In the again the same thing, checkpoints for the Jupyter notebook. Okay, this is not important. Okay, the second thing is that static. In the static you will see the CSS style. Okay, this is CSS style. This is a very small coding of colors for beautification. Okay, and here you can see that in the templates you will see the index.html file. Now here also you will see that it is again the very much simple doc type is HTML, language is English. Okay, and here this is a head. Okay, here this is a title one. Okay, but here I'm gonna create this as a title. Okay, as a I'm gonna use this as a heading. Okay, so here in the heading, okay, I just mention the company name InfosecTrain, okay, and the current year in the body itself. Okay, and now with the help of div tab, okay, here you can see that I'm gonna just go for the prediction. Okay, so see this is a predict method. Okay, so for that reason here you can see that again I'm gonna use a year, I'm gonna use a showroom price. Okay, I'm gonna use a kilometer driven, I'm gonna use a previous owner. Okay, like this I just added all the data, fuel type, okay, either petrol, diesel and CNG. Okay, and here dealer or individual. Okay, and here transmission type. So this is a very simple, you can say that the HTML file. And lastly here you can see that JavaScript. So here you don't need to write a JavaScript code. Okay, just mention this. Okay, all these things. Okay, and then definitely you will just able to run the code and you can create a HTML page, web page. And see at the end, the I just added my LinkedIn, okay, link over here. Okay, and the copyright. Okay, so it's you can delete this copyright as well. It's totally depends on you. Okay, okay, so after this let's come to the app.py file. Okay, so this is all about the index.html. Okay, so I just use the HTML and CSS. You saw the I just uh, type a few 6-7 lines of CSS coding only for coloring. Okay, and now here you can see that this is a pre-processing step, standard scalar I use. Okay, here I just imported this standard scalar from sklearn.preprocessing, and in the app.root, okay, this is for the prediction. So I created the predict function. Okay, this is a full type equal to 0. Okay, Now this is a, you can say that the default value. Okay, if we didn't provide the value, so we can use this value. So after this here, I'm gonna use the if else statement. Okay, so request method is a post method. There are two methods for the extracting the data, okay, from the web page, the get method and the post method. So this is one of the method, post method. Okay, this is a method of you will learn in HTML. And this is the year, this is a year and the data type. Okay, the present price, the kilometers driven, owner, fuel type. Okay, then you can say that if the fuel type petrol is there. Okay, so see there are some, again the if else statement I just added. Okay, fuel type petrol equal to 1, fuel type diesel then 0, otherwise if else, so then just you can say that the contradictory terms. Okay, the year, current year is nothing but the 2022 minus the our previous year. Okay, and the seller type is this. Okay, and for because the seller type, again this is nothing but a categorical column, so that's why I just added a if else statement over here, over here as well. Okay, and this is again the transmission manual, this is again the categorical column, so that's why I added a if else statement here. So after this, after getting all this data, okay, all this data here, I'm gonna make the prediction. I'm gonna use the model which I just load over here. Okay, loaded over here model. Okay, dot pickle file, and here model dot predict. Okay, np dot array. Okay, because here we will get the data into arrays. Okay, so that's why here this is the data I just store. Okay, and I'll convert this data into array and make the prediction. Okay, after making the prediction, we know that, okay, we have to just say that if the output is less than 0, so just use the same index.html HTML file. Okay, to make the prediction, and the prediction will be, sorry, you cannot sell this car. Okay, and if the output is greater than 0, so you can say that you can sell this car at particular price. Okay, in particular lakhs. Okay, xyz lakhs. Okay, and lastly if statement app.run debug equal to true. Okay, so that's all about the app. Okay, you can even create a very simple app. Okay, if okay, after this, okay, if we will have a time, then I'll definitely show you like how to create a very small uh, model, as well as how to deploy the model, okay, with a few line of code. Because here we have a few number of data points, and here we have a mixed data. Okay, some data, some columns are the numeric one, some column are the categorical one, so that's why here I have to just type this much coding. Okay, so again the same thing, just go over here. Okay, for deployment. Okay, to just see our web app. Okay, just go and select this anaconda prompt. Okay, now first thing is that we have to change the directory of this prompt, because this is the current directory. Okay, now here you can see that this is my original directory, not this one. Okay, this one, car price. Okay, let me select this. Okay, I'm gonna type this cd for the current directory. Okay, not current directory, this is a chain directory. Paste it over here and run this. Now I just change the directory of the anaconda prompt, and here you can see that now in this particular folder I have this app.py file, so I can simply run this py file from here as well. Okay, so how you can run this py file from here as well, just use python. Okay, just type python equal the space app.py and enter it, and see here you can see the link. Okay, now see, this is the first heading we have. Okay, and in the last you will see the my name and the LinkedIn profile. Okay, you can also connect me on the LinkedIn. Okay, so first thing is that this one is a year. Okay, you can write the year, any year. Okay, let me go with a, not the year in future. Okay, the sorry, showroom price. Okay, let me use a 5 lakh. Okay, now kilometer driven. Okay, previous owner. Okay, let's go with one. Okay, petrol, yes, petrol. Dealer. Okay, so yes, individual, let's go with the individual. Manual car, yes, manual one. Okay, and let's just predict the selling price. Okay, now after this, here you can see that you can sell the car at 5.6 lakhs. Okay, this is how you can just go and you can find out the you can make the predictions. Okay, so see here, our intention is to show you how you can create end-to-end data science project and deploy that same data science project using Flask. Okay, there are a lot of interfaces, okay, where you can just go and you can deploy your project. Okay, but if you are beginner, if you wanted to create your own data science project, okay, so that's why this Flask is, you can say that, the best interface for you. Okay, now here you can see that, okay, this is a from sklearn.linear model, import linear regression. So let's go and import pickle. Okay, and here you can say that the I'm gonna read the CSV file, and see, when you have to read the CSV file in Spider, so you have to just select the path. Okay, select the path, or there is another way to change the directory of the Python. So if you change the directory of the Python and connect and just set the same directory as the data you have in the same folder, okay, then you will see that, okay, there is no need to just see just add the path over here. Okay, but here my path is this, okay, diabetes prediction app. So here I need to change the path. Okay, sorry, please wait. Okay, so here you can see that after this, okay, after just putting the path over here, okay, and in the last you will see that my data is this house data.csv format. Okay, so let's go and run this. Okay, after this, here you can see that in the variable explorer you will see the data frame. Okay, this is a data frame. In the data you will see that total there are 21,613 data points are there, and 21 columns are there. Okay, so, and I think all the columns are the numeric one. Okay, so I'm gonna select, okay, out of 21 column, I'm gonna select only few columns: bedroom, bathroom, floors, year, build, price. Okay, because to show you, like, with a few line of code we can even create a data science project. Okay, but you have to explain, you can explain all the things. Okay, because creating data science project is another thing, but in interview, if interviewer ask about your data science project, so you have to know all about your data science project. Okay, so here you can see that. Okay, now I'm just extracting, okay, the all the columns which I just listed over here. Okay, which means, okay, instead of all the 21 columns, I just drop all the 16 columns and just use only 5 columns. Okay, now after this, okay, after just dropping all the 16 column, okay, and just selecting 5 columns. Okay, let's go and split the data into x and y. Okay, input and output data set. See, I just created input and output data set. After creating input and output, let's go and split the data into training and testing data set with test size as a 25%, okay, of overall data. So it's totally up to you to set to select a test size as well as a train size. Let's go and run this. And here you can see that I'm gonna use linear regression. Okay, so without any evaluation matrix, okay, here my intention is to just show you how you can just go and deploy your model, okay, with a very few line of code. So that's why I'm not going to show you the accuracy of the model and all about this. Okay, here intention is different, so that's why. So let's go and fit the linear regression algorithm on the training data. Okay, and lastly, let's go and dump your model on the pickle file. Okay, let's means the convert your model as a pickle file. Okay, so here you can see that. Okay, now see, the main thing is that, okay, this is the diabetes prediction app. Okay, here, okay, by default I just store this model dot pickle, okay, into this. Okay, so if I can create this, okay, I can change the folder, okay, and then I can rerun this. Okay, and now I just store this, okay, over here. Okay, house price. Now see the model.pickle. Okay, this is the today's date and the timing. Okay, current timing. So now after this, okay, let's go and open the app.py. Now see the very short, you can say that the very short coding of Flask app. Okay, now first thing is that just import Flask, okay, from the Flask as well as a render template and request. Okay, because this template is for the HTML and request is to collect the data. Okay, see, request is to collect the data, and after that just import numpy as np and pickle for loading your model. Okay, so here I'm gonna create a Flask app. Okay, then I'm gonna load a pickle model, which is a model.pickle. Okay, after loading a model, so I can use this model, okay, for the prediction purpose. So see, I just created a index function and render template. Okay, and this is my HTML index file. Okay, and in the app root itself I'm gonna use this thing, okay, for the prediction purpose. Okay, you can use any method, get and post. Okay, this is totally up to you. These are the two methods of HTML. Okay, whether you have to for like these two methods will you can select this any one method for importing your data, okay, from web app. Now this is a request.form, bedroom, bathroom, floor, years built. Okay, now let's convert this four values into the arrays. Okay, why you have to convert this? Okay, because if you convert this, so it's very easy to just go for the prediction purpose. Okay, so after this let's go for the prediction purpose. Okay, after, okay, after make the prediction by using the model. So see here I just load the model, which is a pickle model, and I use the same model dot predict. Okay, I'm gonna use this model for the prediction purpose, and I'm gonna use the array, which is all the values. Okay, and in the last render templates, okay, in the index.html data and the prediction. Okay, and lastly app.run debug equal to true, okay, by using a if statement. Okay, so this is all about a small line of a very few line of coding. Okay, open the folder, okay, of the house price prediction app. Okay, and here you will see the again the very small line of coding. Okay, see, this is a very small line of coding. Okay, this is the head of the HTML file and this is a body. Okay, you see, means with the help of very small line of coding, okay, we can even create a Flask app. Okay, so don't bother about coding. Okay, and you can see that the CSS, okay, this is the main.csl. Again, this is a very small. Okay, why we are using CSS? To just for the beautification purpose of our web page. and see this is HTML, and here this is a title. Okay, and here see this in the body. Okay, I'm gonna just entered the all the bedroom values, bathroom values, floor years of build. Okay, like this, and lastly just go for the prediction. Okay, just go for the prediction. So see here data. Okay, and this data is nothing but this one. Okay, this data is nothing but this one. Okay, this one data. Okay, and we know that data equal to the integer value of prediction. Okay, so this is a prediction. Okay, so in short we are going to make the prediction. Okay, so let's again reopen this. Okay, anaconda prompt. Okay, again I have to change the directory. Okay, I have to set this directory. Okay, cd. Okay, change directory, enter it. Okay, and again see this is app.py file over here. So now just go and type python app.py. Okay, and enter it. Now again go and copy this one. Okay, and so now see, now this is a very small and very specific flask app. Okay, you can just go and select. Okay, you can just go and just even use this. Okay, cursor. Okay, to select the number of bedroom, number of bathrooms. Okay, number of floors. Okay, year of build. Okay, let me go with the 5 and make the prediction. Okay, see the house price. Okay, see the house price. Okay, so this is how you can go and you can build your end-to-end data science projects and deploy your model using Flask. Okay,